Alright, so we're going to start continuing to work with this new form we've discovered the last couple of days called vertex form. So now, just to summarize, you've now seen three different forms of a quadratic. You've seen standard form, factored form, and now vertex form. Eventually we want to get to the point where we can move between all of these forms freely. So we're not quite there yet, but there's a lot we can do already. So if we're in standard form, remember that we can always get to factored form by factoring, since we spent all of last unit on. And if we're in factored form, we can always get to standard form, so basically going the other way here by expanding. Okay, now working with vertex form is a little bit different. Now we haven't actually done much of going from different forms to vertex form yet, so we're going to look at the different ways we can do that today. And we're also going to look at going from vertex form into some of these other forms as well. So as a rule though, because you notice one thing about standard form is that everything's all expanded out, no brackets, all your like terms collected. And it's going to be very, very similar to expand from factored form to standard form as is from vertex form to standard form, and that is to expand and simplify. We'll do some examples of that today. Before we get into that, I just want you to think about, now that we've seen three forms, which form is it easiest to determine the certain features of the parabola. So if we were trying to find the vertex, which form would be the easiest form to look at for that? If we're trying to find the x-intercepts, y-intercept, axis, again, which form would be easiest to determine just by looking at the equation? So take a minute and think through that one, and in a second we'll go through the answers. Okay, so again, looking at the three forms here, the vertex would be easiest to get from vertex form, because it's just going to be the hk value in the equation. Okay, the x-intercepts are easiest to get from factored form, because you say each of your factors is equal to 0, and you can solve the x-intercepts relatively quickly. The y-intercept is easiest to get from standard form, because it's just your c value. Okay, and the axis symmetry, you're used to getting that one from factored form by averaging out your x-intercepts, but now that we have vertex form, it's easier to get it from there, because it really just is the h value in your equation. Okay, so now what I want to do, there's a few equations here in vertex form. I want you to state the vertex, how many zeros there are, and the equation standard form for each of them. So I'm going to go through the first one together with you guys. Give myself some space here. So first thing I'm going to do here, just by looking at the equation here, I should be able to read off the vertex as being at -5, -4. -5, -4 will be my vertex. Now, to get the number of zeros there, what's going to help me is looking at a quick little sketch. And my sketch here does not have to be very, very accurate. So I know my vertex is at -5, -4, which is going to be somewhere down here. Okay, and the other thing I need to figure out here is that my parabola opens down. How do I know it opens down? Well, again, remember, looking at my a value here, my a value here is negative. So because of that, we're going to open down. So my vertex here is below the x-axis at -5, -4, and my parabola opens down. Once I have that quick little sketch done, how many x-intercepts do I have? How many zeros do I have? Well, this parabola does not cross the x-axis at all, so it actually has no x-intercepts or no zeros. Okay, so we don't have to do tons of work to find that out. All we have to do is create a quick little sketch, and then just by looking at that sketch, we could see how many x-intercepts there were. Now, to get to standard form, slightly takes a little bit longer. So I have y equals -3 bracket x plus 5 squared minus 4. You'll remember that standard form has everything expanded and simplified, and that's what we're going to do here to try and get this into standard form. So right now I have y equals -3 bracket x plus 5 all squared minus 4. So I'm going to expand everything out. Let's make some space here. And I'm going to need to, first thing, just to be careful with your algebra here, common mistakes I see, you cannot multiply -3 into this bracket right now because we have an exponent here on the bracket. And when you expand this bracket, do not tell me, please do not tell me that this is equal to x squared plus 25. Okay, lots of kids do that as a mistake. Remember that it's not correct. X plus 5 all squared, remember, is just x plus 5 times x plus 5. So how do we expand that? Well, we have to expand that using an array or using distributive property. So we're going to have a 2 by 2 array here. with x plus 5 on the outside, and we fill in with multiplication. So x squared plus 5x plus 5x plus 25. Okay, so putting that all together, and erase this incorrect stuff here. Putting it all together, I'm going to wind up with x squared plus 10x plus 25. Okay, and again, with this minus 4 carrying around. Okay, so we've done the hard part here. It's just a matter now of expanding through and simplifying, collecting your like terms. So the negative 3 distributes through this bracket right here, so we wind up with negative 3x squared minus 30x minus 75. Okay, and again, this minus 4 carries over. So it simplifies into final answer negative 3x squared minus 30x minus 79. Okay, and now we're in standard form. Okay, so I'd like you to try repeating this process for B and for C, and I'll reveal the answers in a couple seconds there so you can check them, and then we'll run through any steps that may have caused us some problems. Okay, so take a minute here to check your answers. So for the second one, vertex is at 6, negative 9. If I do a quick little sketch of that, that vertex is down here below the x-axis. The a value is positive, so we open up. So we can see from that quick little sketch it is going to cross the x-axis twice. We have 2 zeros or 2 x-intercepts. I showed a couple steps for the expanding and simplifying here, so hopefully you wind up getting the same answer as me, 2x squared minus 24x plus 63 for standard form. For the last one here, this one can be a little bit tricky, only because it doesn't necessarily look as much like vertex form as some of the other ones because there's no k value here, right? It just means the k value is 0. We wouldn't write in a plus 0 here because it doesn't actually change the equation. So the vertex here is at negative 18, 0. So your vertex is on the x-axis. So if your vertex is on the x-axis, it doesn't matter whether we open up or down. This one opens up, but either way, it's only going to have one x-intercept. The x-intercept occurs at the vertex, negative 18. Okay, so one x-intercept for this one, and if you do the expanding and simplifying, you should wind up with 2x squared plus 72x plus 648. One thing I want you to notice looking at all your answers for this one is if you look at the a value from standard to vertex form, it's always the same. So if you see here, for C, a value 2, a value 2. For a value of negative 3 in both standard and vertex form, and again in B, a value of 2 in both standard and vertex form. And that's kind of important because, we looked at factored form, and factored form doesn't always, if you look at the a value in front, you can potentially fall into a trap. We saw some examples where that a value could mislead you as the direction of opening, but we knew the a value in standard form always told us the direction of opening. Well, it's going to be the same thing for vertex form. If we have the a value from standard or vertex form, we know it's going to tell us whether it opens up or down, because it is going to be the exact same value. Okay, so let's try a couple other examples here, trying to put everything together from the last few days. So here we want to find the equation that is going to be defined by the transformation of y equals x squared from this mapping rule. And then once that's finished, you're going to find the zeros. So first things first, let's find the equation. So looking at the mapping rule here, we can get a lot of information about the equation in vertex form. So I'm being told that the vertex moves right 5 and up 7. So that's going to tell me right away that my vertex is going to be at 5, 7. Okay, once I have that vertex, that gives me the h and k value for my equation vertex form. So I'm just going to write that out here. Y equals a bracket x minus h all squared plus k. And again, I'm being told the vertex is 5, 7. So I'm going to put that in. So I'm going to have x minus 5 all squared plus 7. Now to find that a value, normally I'd have to sub in a point, but I don't even need a point because, again, I have it from my mapping rule. Every y value I have is multiplied by negative 2. So that tells me I have a reflection in the x-axis and a vertical stretch with a factor 2. So that gives me my a value. So I can just put that in the equation right away. My a value is going to be negative 2. So right away I have my equation after a couple steps in vertex form. Okay, so now from there I want to actually find the zeros. Now if you look at this equation right here, If I'm trying to find the zeros are the x-intercepts, and those always occur when y is equal to 0. Okay, because the points are on the x-axis, the y value is 0. So if I put in 0 into this equation for y, I get an equation that, in theory, I should be able to solve for x. Well, how do I solve for x? I do so by rearranging the equation. So looking at this one here, if I were trying to isolate x, there's a lot going on here. The algebra can be kind of tricky. So eventually I'm going to have to take a square root to sort of get rid of that squared, and I'm going to have to add 5 to get rid of that so I can get x by itself. But first things first, I'm going to move that 7 over by subtracting it from both sides. So subtract 7 from both sides of the equation. Okay, and again, I'm going to start solving for x piece by piece. So I've subtracted 7 from both sides. I can't take the square root yet because this negative 2 doesn't have that squared. So I'm going to divide both sides of the equation by negative 2. So now on the left side I have 7 over 2, and on the right side just have x minus 5 all squared. Okay, and now I can take the square root of both sides of the equation. Now, when I take the square root, I have to be very, very careful here. It's not just root 7 over 2. There's actually two possible values. It's going to be plus or minus root 7 over 2. Okay, and the reason for that being, I'll work on that off to the side. Let's say I have x squared equals 25. There's actually two possible answers to this because 5 squared is 25, and negative 5 all squared is also 25 because that negative gets squared as well. So there's two possible answers to x for this equation right here. So if I were to solve this equation, I would say that x is equal to plus or minus 5 when I take the square root of both sides. So the same thing here, even though the numbers are a little bit uglier with fractions. When I take the square root of both sides of the equation, I'm going to have plus or minus root 7 over 2. If you forget that plus or minus, it actually is quite important because you're going to lose one of the solutions. So, for example, look at this equation. I know my vertex is at 5, 7. So 5, 7 is somewhere above the x-axis here, and my a value is negative, so I open down. So I know I'm going to get two x-intercepts here when I solve this. If I don't have the plus or minus here, I'm going to lose one of those x-intercepts. So to finish this one off, I'm going to add 5 to both sides of the equation. So I have plus or minus root 7 over 2 plus 5. So this is actually my 0 is my x-intercept. So what it actually means, again, I have two x-intercepts. One of them is going to be at root 7 over 2 plus 5. And the other one is going to be at x equals negative root 7 over 2 plus 5. Okay, so you can leave your answers like this. This is the exact value. They're not rounded. If you needed to do some work with them, you could run them through your calculator to find the decimal equivalents. Just make sure you round them to two decimal places. Just to make sure you can do that, run each of these through your calculator and see what the decimal equivalents are. So the first one, square root of 7 over 2 plus 5, should give you approximately 6.87. And the second one should give you approximately 3.13. Okay, so again, normally you can just leave your answer exact. If I do ask for two decimal places, please make sure you put it through your calculator and find those answers. Okay, but you can see there how we can find the zeros of the quadratic equation vertex form. So you set y equal to 0, rearrange the equation, and solve for x. Okay, so this one puts a lot together at once. So I want you to find the equation of the quadratic in standard, factored, and vertex form. I'm going to give you the y-intercept. I'm going to give you the zeros. Okay, so this one's a bit of a challenge. I want you to try and think about this one. You have to find all three forms. It doesn't matter which one you start with, but based on the information I give you, decide what form would be easier to start with. Try and work through as much as you can, and when we get to part 2 of the video, we'll run through the solutions together. Okay, we'll see you over there.